Hi, one of the applications we have for factoring is equations, and the basic part about this is that we can use something called the zero product property, which, like I said, works for equations. It's a pretty simple concept, but I just want to make sure that everybody realizes how this is connected to factoring. It says that basically, if you have two expressions that are multiplied together that are equal to zero, then that means that either the first expression must equal to 0 or the second expression must equal to 0. Now, we can start this off right away with some simple concepts. If I say 7 times d equals 0, well, obviously 7 is not equal to 0, so that means that the d must be equal to 0. And the next case, w times 25 equals 0. Same deal, the w must be equal to 0 because the 25 obviously is not. A little more complicated because, as I said, the a or the b are expressions. So in this case, the a, let's say, would be 12 times the b, which is the expression m plus 9. So it means that either 12 must equal to 0 or m plus 9 must equal to 0. Now, m plus 9 equaling to 0 is a mini equation which says that the m would have to equal to -9. Now, right from the start, I'm going to ask you to try and do this kind of work in your head and realize what plus 9 is equal to 0 and say -9. And we're going to see a couple more shortcuts about that in a couple of seconds. So the next expression, I have b plus 3 times c minus 7. Now, in this particular case, there are two unknown quantities, or both the factors have something that's variable. So that means either the b plus 3 must equal to 0 or the c minus 7 must equal to 0. So b is equal to -3 or c is equal to 7. As I said, you can just sort of guess your way into that. Say that, well, -3 would make the first bracket 0 and +7 would make the second bracket 0. Notice, however, we have two answers for this question. And in a lot of the examples we're going to be seeing in the next few days, that's going to happen quite often. So the next question has three factors. You could have possibly three different answers. However, 2 is never equal to 0, so I don't have to worry about that one. But I do have to worry that the n minus 3 could possibly equal 0 if n was equal to 3, or in the next one, if n was equal to 4. Now here's where I'm going to talk about that idea of working this through in your head. Yes, you could be solving 2n minus 8 equals 0 and bring the 8 over to the other side and divide both sides by 2, and that's going to get you the answer that I just said, n equals 4. But the shortcut rule is going to be you take the constant amount in the bracket, okay, and these are normally binomials are going to normally have one variable term and one constant term. So you're going to take the opposite of the constant and divide it by the coefficient. In other words, positive 8 over 2. All right, n equals positive 8, right? So I'm emphasizing that we're taking the opposite of the -8 over 2. And that's how we're going to work these questions through. And we're going to see that again right now in the next question. So I have 2h minus 7 times 3h plus 4. The answer to the first bracket, you're expected to do it in your head, is to say that h is equal to positive 7 over 2. Or, and that's, we link these together with the word or, h is equal to the negative of 4 over 3. Now the question often comes up, students say, well, can we answer as decimal? That'll work, except that if the fraction doesn't work out to a nice, easy decimal, you're going to be required to leave it in fractional form because that's exactly the right answer. Now, let me make this clear. This is step 3 of a 3-step question. Section 2 here is showing you the 2 steps, step 2 and 3 of a 3-step question, in that we have a trinomial equal to 0. However, it's not in factored form, okay? So basically, you have to factor first, and then you're going to turn it into the kind of example we just worked on. So simple trinomial here, you should be able to do this pretty quickly by now, is going to be a minus 5 and a minus 4 And my two solutions are going to be that A equals 5 or A equals 4. Straightforward enough, I hope. Question B is similar. This one, however, when I go to factor, I put my K and my K, and I'm looking for factors of 19 that subtract to get 7. Well, it's kind of weird. I didn't actually intend this to happen, but this question doesn't factor. Okay, it's a DNF. However, it doesn't mean that the question cannot be solved. It's just that we don't have the techniques for solving this yet. When you get to secondary 4, you learn something called the quadratic formula that's going to allow you to get that answer in an alternate way. Question C. So, oh, by the way, so you just stop that DNF. There's no solution for now. Question C. Question C, I'm going to be taking out the letter C, and that's going to leave me with C squared plus 7C plus 12 equals 0. And now you can factor that with 3 and 4, right? The factors of 12 that add to 7, and that are going to be equal to C plus 4, C plus 3. Oops. Your answers, C equals -4 and C equals -3. But hold on a second. There's going to be another solution in that C could be equal to 0. And as you're going to find out, the highest exponent in the question on the variable is going to tell us the number of solutions that we can get in any particular example. We'll do a couple more of these and then you'll go off on your own. I want to jump to letter E. This one has a common factor of 3. And there's a mistake in this question, by the way. That's supposed to have an E squared. So 3E squared minus 30E minus 72, you're going to take out the 3 and be left with E squared minus 10E minus 24. And there's the trinomial can be factored as E minus 6, E plus 4. And your two solutions that we pull out of that are going to be E equals 6 or E equals -4. Notice this time we don't get a solution from that 3 because there is no variable on that factor. And I forgot the equal sign here. E equals -4. Letter F is a difference of squares question. And the reason it's worth doing is because here we're going to wind up with that idea of the fraction. So you have the factoring of that difference of squares, and it's going to be equal to F is -5/2. Remember, it's the constant over the coefficient, the opposite of the constant over the coefficient. And the next one's going to be +5/2. And questions G, H, and I, these three questions are the 3-step questions. The reason that there's a third step in these examples is that you have to isolate you have to get everything on the same side equal to 0 first. So I'm going to bring the 7 over and get x squared plus 6x minus 7 equals 0. And that's going to factor. And then I'm going to get my solution. So step 1 is to bring everything to the same side. Step 2 is going to be to factor. And step 3 is going to be to pull out the solutions, x equals -7 or x equals +1. A reminder in letter H here, it's always best to bring everything to the side where the exponent is going to have a positive coefficient. So the 2d squared on the left side here, the 2m squared on the left side, those guys are going to stay on that side and you bring everything over. Okay, so this would turn into 2d squared minus 10d plus 8 equals 0, and you're supposed to keep the equal signs lined up, and that's not so clear in this question. Remember that anything that crosses over the equal sign, just like in that previous question, the -7 went to the other side, is going to be opposite sign. And you would take out the GCF and then factor to find out your two solutions. In this case is going to be D minus 4, D minus 1, and so your answers, your solutions are D equals 4 or D equals 1. One extra detail that was mentioned is that these are the values that would make the brackets 0, and that's another name for these solutions. We call them the zeros. So you might use that vocabulary every once in a while. Hopefully that's enough for you to get started, to get your questions going. And good luck with the practice on that. Thanks.